Cool. Well, thank you everyone for tuning in for this first presentation. I'm a little excited, so I'm going to try to speak slow. But yeah, I hope you all have a really good morning or evening. I think we're having a lot of international people on the call, which is one thing that I really appreciate about the program here. So my name is Jennifer, and I'll be talking about innovative approaches for coastal aquaculture, and specifically how we can harness seaweed farming for water quality and livelihood resilience in West Java, Indonesia. But before we get into that, I want to start with a little bit of a background story. As you may hear from my accent, I'm not from the US. I am actually from Germany, and I grew up in a pretty small village in the Black Forest. You could see it up here in the background of this picture. This is a little observatory tower that I used to bike to after school. And so I was really, growing up in the forest, surrounded by nature, had a big appreciation for it. And when I went to university, I started realizing the impacts that we as humans have on our environment. And I started getting more involved with nature conservation. So, for example, I was participating in studies that looked at the drought effects on forest mammals. And so you could see a picture of a wildlife camera we put out that pictured a squirrel here feeding from a water hole in the forest. This passion for nature conservation then eventually led me to California, not to UC Santa Cruz, but to the Cal State University in Monterey. And I worked on a whale watching boat over there while I was in school. And I also participated in some agricultural classes. And I got really aware about the food system and the huge impact that our food system has on the environment. And one thing that always just blew my mind is that there's about 8 billion people on this planet, right? And we're all eating up to 3 times a day, sometimes maybe even more. And that's a lot of food, that's a lot of resources, that's a lot of choice. And it really started getting me interested in the whole idea of like, how does our food system work? What's working well? And there's a lot of things that are not working well. And this theme of the blue revolution started coming up, especially as I started thinking about the way that humans consume protein. And so that ultimately led me to India, the second biggest producer of fish and shrimp products across the world. And I started engaging with a local organization called Fish Welfare Initiative. At the time, not local, but we actually started building up a program in India, working with fish and shrimp farmers, and really understanding that the Blue Revolution had its own challenges, as every part of the food system currently does. And one thing that really struck me is that these farmers, about 200 farmers that we're engaging with, they have a lot of issues. There's a lot of issues in fish and shrimp farming, all kinds of aquaculture practices. A big one is a lack of quality inputs, right? Like those farmers do not have access to good seed, which is like the baby fish and shrimp. They do not have access oftentimes to good feed, to medicine, to all the things that they would need to have a good culture. They also suffer from pretty poor water quality in a lot of regions. They may not have access to clean water. They may not have the means to purify their water if it's not clean. And all that is compounded by general lack of training and technical support, right? They sometimes don't even know how to check for water quality. And even if they do, they don't know how to solve it in some cases. And that really creates a big issue and creates a lot of suffering for those animals in the system, but also the farmers, because ultimately what happens is a lot of animals get diseased or died. And the ultimate thing that just makes it even worse is a changing climate. So you have longer drought periods, less rain, right? Then you have a lot of rain all of a sudden, and then you have higher temperatures, and that just makes everything even worse. And this really showed me the harsh realities of aquaculture, which was often lifted as this great opportunity and like the one problem solver to the food system. And it really severely affects the livelihoods of oftentimes smallholder farmers, which are very common across Asia, to the point where some are left with huge debt and just move out of aquaculture. And this made me wonder, can we enhance the resilience of these smallholder aquaculture farmers? And my research over a lot of corners ultimately led me to this topic of species diversification. And specifically, I got really interested about seaweed, because seaweed, I will use this term very broadly, but it's a vast group of macroalgae, right? Or you could call aquatic plants. So you could see a picture of one here on the right, but they're very powerful. They have shown in various studies to improve water quality. So a lot of species are known to take up harmful nutrients, they purify the water, they have buffering capacity against diseases, which I'll talk a lot about a little later. And also there could be high profit margins if the supply chain is set up the right way. They also have a fairly low risk for mortalities and just in general farming failure because it's an aquatic plant, usually a lot easier than farming aquatic animals. And they have shorter farming cycles. So instead of waiting for up to 12 months for a full cycle, for example, fish, or 3 months for shrimp, you could harvest seaweed after about 30 or 40 days sometimes. And my research brought me across a lot of organizations that I talked to, as Anne said, were engaging a lot with kind of the landscape and trying to understand the problem. And one that got me really excited is this organization called Rongbiant, which works in Vietnam. And what they did is they did a seaweed and shrimp co-culture. So they farmed these two species together. And what they found is that they actually got a lot of benefit from having seaweed in the farm. Not only did the shrimp survival rate increase by 20%, but they've harvested the seaweed, made it into shrimp feed, sold it, and they increased farmers' incomes twofold by doing that. And so examples like this got me very excited about the possibility of farming shrimp and seaweed together and enhancing the resilience of these systems. And so with this capstone, what I set out to do is to explore two key objectives. The first one on the left here is how can shrimp seaweed co-culture improve water quality? Like, is that actually possible? So we conducted a scientific experiment comparing two different systems that we expected would do that. And then the second one was whether shrimp seaweed co-culture improves farmers' income, right? So it's all great if, it improves water quality, but if it isn't interesting to farmers, they're never going to take it up. So that's what we tried to explore. Now, there's a lot of things that are wrong with current economic models for aquaculture. So I actually tried to build a new model, which I'll dive a lot more into later. And I was very lucky to find a local team in Indonesia who had been exploring these questions for much longer than I have. And this is Sambung Asa. They're a local group working to advance seaweed farming in Indonesia. And they also collaborate with some shrimp farmers. So they actually had already tested some ideas around shrimp and seaweed farming. And they were interested to collaborate with me to further explore this question. So that's what we set out to do and explore together. And if you're here on the call, Sambung Asa, it's great to have you here. And you could see a picture of them also here. So now on our journey around the world, I want to take you to Indonesia. And specifically the region of West Java and the Belanakan aquaculture region, where there's a lot of fish and shrimp farming going on. And this is where we set up an experiment to explore shrimp and seaweed farming. And that is the first objective. So does shrimp seaweed farming co-culture improve water quality? This is what the experiment looked like. You could see a picture on the right of what the setup is, and on the left kind of the technical outline of what it looked like. So we have control water, we had source water, which was polluted with nutrients. And we got that water and we tested two different systems. On the left, you could see a system where we farmed shrimp and gracilaria together. So we put that in a few of these tanks that you could see here on the right. And on the right, we did what we call a pre-filtration system. So this is where we had one tank all the way on the front here with gracilaria that purified the water, and then we used that water for shrimp tanks. And so what we're trying to see is whether one of these systems is better, and if we're trying to advertise the system, whether maybe we should push more for one than the other. And so there have been studies around just farming shrimp and gracilaria already for general performance of this farming system. But what we hadn't found before was a lot of studies comparing different systems. And that's why we thought it was important to do this study. And what we found is that there was indeed an improvement in two key water quality parameters, namely dissolved oxygen and turbidity, both very important parameters for shrimp farming. So that seemed pretty promising to us. We also found that all the tanks that had shrimp had an average or above average survival rates in 5 of the 6 tanks. And that was pretty promising too, because again, mortalities are a big issue on shrimp farms. And the shrimp had a pretty good growth. They weren't growing a lot bigger, but they also weren't growing smaller. So they were just growing at a normal rate. Again, with more survival, that just means more profits. And so we were like, okay, well, this sounds awesome. Like this seems to work in both systems. So there's like kind of a menu that we can give farmers, whatever works best for them, pre-filtration, co-culture, whatever would work. But then the second question still stood in the room. Does this co-culture actually improve farmer economics? Like, would this actually be financially viable for them? And now the issue with traditional economic models for aquaculture is that they really only take into account expenses, revenue, and maybe some technical number for like average survival. But the problem with that is that you're missing a lot of risk factors, right? You're missing things that affect your survival. So, for example, there could be extreme weather events, there could be disease outbreaks. This may differ in regions, this may differ during seasons. And there's all these compounding factors that affect your survival rate, where it's very hard to just put some average survival rate on any culture. And ultimately, these risk factors trickle all the way down to your profits, right? Because the fewer animals you have that actually survive until the end of your cycle, the less money you are going to make from selling them. And so, what I tried to do is build an economic model that takes all these risk factors. There were 12 in total that we identified, and take them and build them into the economic model, build them into the calculations for profits, and really have them be reflected in what the true outcome of a shrimp culture or a seaweed culture would be, taking all these things into account. The interesting thing is that farmers often talk about shrimp farming as a gamble. That's what they call it themselves, because there is a really high profit margin if everything goes well, but it almost never does. And if it doesn't, then it can be very devastating. And that's really what this economic model is trying to capture with the risk factors is let's write down what the gambling here really is, right? Because you shouldn't have an economic model built on gambling. And so I ran a case study together with Sambung Asa, and we compared 3 different systems: a shrimp monoculture, so only shrimp, a seaweed monoculture, only seaweed, and then a seaweed shrimp co-culture. Again, this is a combined system with seaweed and shrimp. It's worth noting, and I could talk more about in the Q&A later, that the shrimp stocking density in the seaweed shrimp culture is a little higher than in the monoculture. But in any case, the seaweed monoculture and the seaweed shrimp co-culture always outperformed the shrimp monoculture in terms of profits. So the bars that you see here is the minimum, average, and maximum profit that a farmer could expect over a 5-year timeline, the net average profit that they would get from this culture. And again, it's very clear from these numbers, and they may differ from, specific scenarios, but like there's a big difference between a shrimp monoculture and seaweed shrimp. And this is actually because seaweed buffers for excessive mortalities. It can improve survival in shrimp seaweed co-cultures by 85% compared to a shrimp monoculture. And that's because seaweed can actually reduce the disease load, right, the pathogen load in the water, and help thereby decrease some of these risk factors that I talked about earlier. And also, having seaweed in your farming cycle, again, it can be harvested more often. So instead of waiting 90 days now to fulfill your full shrimp cycle, every 40 days you just sell your seaweed. So you have additional income coming in. And often you could propagate the seaweed a little bit. You don't have to buy every time, like with shrimp, new seed. So that makes it a very, very profitable crop. So this seems to be attractive, right? Like this should be something that farmers technically are interested in. And in fact, we had some farmers reach out to us even just after the experiment to ask whether this is something that they could look into further. So then I was wondering, can we scale such a more resilient aquaculture system? And I think we could. And I think actually Sambung Asa has shown in other parts of Indonesia, they are working with farmers already. They are farming seaweed in other parts. And farmers are interested in that. And there are similar conditions that could really make this scalable across Indonesia. This could even be scalable potentially to other countries with similar contexts. For example, India, where I went with a colleague of mine from Fish Welfare Initiative, and we visited a local organization called Seaweed's Energy, who has been experimenting with putting seaweed into shrimp ponds, and they've seen pretty promising results. So there's a lot of pioneers out there who are already doing this work, and I think we could really move towards a system where we can integrate these species, get better results for the farmers, but also create better environments for the animals within these systems. So I think there's an opportunity to reduce the risks of common farming systems in aquaculture, increase resilience of the farmers within those systems, and ultimately transform our food system that way. And before we move into questions, I would like to thank a few key people who really made this work possible. Both my advisors, Galina Hale and Anne Kapczynski, are on this call today. Thank you very much for all the guidance and the many, many questions that you had to endure. And specifically the whole Sambung Asa team, but especially Julius and Judith, who supported me a lot, not only in person, like providing, the comfort of their home to me while I was in Indonesia, but really opening up their organization to this collaboration with CSP. And I'm very, very grateful for that. To the CSP cohort for all your feedback. Shreyang from another organization, Shabrata from our organization, you gave me a lot of really useful insights. Thank you for that. And I'd love to take some questions. Thank you.